Okay, here we go. We have problem number 5 from 2008. Problem number 5 from 2008. And one thing that's nice about this problem here is it talks about a slope field. Part A says, sketch a slope field. And a slope field is actually pretty easy. If you just name a point like -1, 0, this tells you the slope if you plug in the y value. So the y value is 0 and the x value is -1. And so you would get -1 over 1. So you draw a slope of -1, just a little segment through there. And then if you try another point like -1, 1, when you plug in 1 for y, you get 0 on the top, you get 1 on the bottom. So you get 0 over 1. So that would be a slope of 0. And then we're going to plug in -1, 2. And you can see you're going to get 1 in top and you're going to get 1 in bottom. So a slope of 1. Doesn't ask for anything on the x-axis because when x is 0, it's undefined. So we come over here and we look at 1, 0. And as you type in 0 for y, you get -1 on top and you get 1 on bottom. So it's a slope of -1. 1, 1. Notice again when you plug in 1 for the y value, you get 0 on top. So that's going to be 0. And then 1, 2. Plug in 2 on the top, we get that value of 1. And on the bottom, we get 1. So slope of 1. So it actually looks the same as the last side. But this one here, just a little bit different. If you type in 2, 0, notice you get 0 here, so that's -1. The bottom you get 4. So it wants to see a -1/4 kind of a flatter line. Notice that for 2, 1, if you plug in 1 for y, you get 0. And then finally, if you plug in 2, 2, notice that you get 1 on top, you get 4 on the bottom, so it's +1/4. So that'll be sufficient for that's part A there, for a slope field. Part B says find the particular solution. And this is where we do the separation of variables thing. And separation of variables is just going to require that we get the x's with the x's and the y's with the y's. So I end up with, in this situation, dy is equal to y minus 1 over x squared times dx. And then if you divide the y minus 1, 1 over y minus 1 dy is equal to 1 over x squared dx. So just doing that separation of variables is enough to be able to give you some points. But it also wants us to find the particular solution. And in that situation, we do an integral. Okay? And as we look at the integral, the antiderivative of 1 over x squared, or the antiderivative of x to the -2, is going to be -1 over x plus a constant. This one, the 1 over y minus 1, we just did that in class. You remember it's natural log of y minus 1. And so now I'm tempted to plug in my initial condition. The initial condition here, it says, is f of 2 is 0. So if you look at f of 2 is 0, what that means is it goes through the point 2, 0. The x value is 2, the y value is 0. So if the x value is 2 and the y value is 0, notice how I get a negative here. You can't take the natural log of a negative. It's illegal. So let's go ahead and get rid of that first before we try anything. And we'll take it to the e power. I'm left with y minus 1 is equal to. In this situation, I do get e to the -1 over x plus a constant up top there. Okay. And now in this situation, you can really go ahead and deal with your values. So you can plug in that 2 for x and that 0 for y. So -1 is equal to e to the -1 over 2 plus c. Okay? And you could rewrite this as -1 is equal to e to the -1/2, and that plus is the same as multiplying by the same base. E to some constant. Okay? E to some constant. So we're going to, this ends up being e to some constant is just some value. We'll call it k. So negative 1 is equal to k times e to the negative 1/2 power. And if we divide by e to the negative 1/2, you see the negative is in the denominator, so it's just negative e to the 1/2 power is equal to k, that constant out front. So if I wrap that all the way back around, okay, if I wrap that all the way back around to this guy, I have right here, I have y minus 1 is equal to some constant k times e to the negative 1 over x. Now you know that that constant is negative e to the 1/2 power. So y minus 1 is equal to negative e to the 1/2 power times e to the negative 1 over x. If you'd like to combine those, you can, or you can leave the e just like that. I add the 1, I get y is equal to 1 minus e to the 1/2 e to the negative 1 over x. Now again, they would allow you to write it like y is equal to 1 minus e to the negative 1 over x plus a half. That would be acceptable as well. Either situation, they'll be fine with that. Finally, part C says, find the limit as x goes to infinity. And so if we look at y is equal to 1 minus e to the 1 over x plus a half, and we let x go to infinity in this situation, we would end up with 1 over a really large number, which really ends up being 0. So y is equal to 1 minus e to the 0 plus a half, okay? Which would be y is equal to 1 minus e to the 1/2. That's a suitable answer. A lot of people recognize that the 1/2 power is square root, so 1 minus the root of e. And there it is. Not an easy problem, but, I think as you have it in your notes, there's some good stuff there. Remember that each problem in the past has always been worth 9 points, and that, generally the average is about 3 points per free response problem. So we'll give another one a shot here. And I really do feel like the last one you're going to find to be the easiest.